All right. Very good morning, very good evening, everyone. Welcome back again for this demo sessions. Right. Let's quickly recap in 1 or 2 minutes what we discussed yesterday, and then we'll get started with some technical discussion around rack concepts and the rack architecture part and rack networking. So if I can open my notepad, what we discussed yesterday, we started with the introduction about your instructor. That's me. I gone through my entire journey in this IT world from past 15 years. What are the major accomplishment? What are the major companies I worked, and what are the major areas I worked in the past 15 years in this IT industry. I'll be the one who will be teaching this entire rack course, and then we went through a course curriculum in details. We went ahead and then discussed about the course content, what what all included in this course and what is not included in this course. And also I was open to take any feedback or any topic is missing, and I'm happy to include that topic in upcoming sessions. So we went ahead each and every topic and what are the importance and what all will be covered in this entire rack course curriculum. And then we discussed about the course duration, course timing, course fee structure, and the upcoming batch details. So anyone not able to join this particular batch, they can feel free to go to my blog, and then they can keep a watch on this particular upcoming batch details so that you can enroll for the next batch. And then these yesterday and today are the two demo sessions, and actually the course is going to start on next weekend, next Saturday onwards. That's the 4th Jan 2025. In IST time zone, it will be 8:30 a.m. IST to 12:30 p.m. IST, 4 hours on Saturday and 4 hours on Sunday. And in Eastern time zone, it will be Friday and Saturday. It will be 10 p.m. EST to 2 a.m. EST. So for Eastern time zone, it will be Friday and Saturday, and for IST, it will be Saturday and Sunday, the weekend batch. This is a weekend batch, 4 hours on Saturday and 4 hours on Sunday, and we should be able to complete in 5 weekends. And since this is a paid training, the course fee is going to be 15K Indian rupees or 185 US dollar. Will be conducted via Zoom session, online mode, and we'll be covering 19th version. Right, so we got couple of registration yesterday. We have added them to WhatsApp group, and then yet to grant the Google Drive access. Probably after today's session, I'm gonna take care of that. I'll gonna grant the access on the Google Drive. So pretty much who are gonna register for the course, they will be getting the access on the Google Drive, and then they will be added to WhatsApp group. So WhatsApp group is primarily for all the communications, any questions, queries, or any issues, challenges, or any support. We'll be using the WhatsApp group for a single point of communication, and will be added to WhatsApp group all the registered students. This is only for dedicated for registered students, not publicly available. This WhatsApp group, and also the registered student will be getting on the Google Drive access. This will be 4 links. The first link will be for all the course materials and course PPTs and lab exercise workbook and the ready labs. All those will be available in the link one. And the link two will be all the softwares, tools, interview questions and answers, automation scripts and patches. All those will be available on this link two. Link three will be previous batch recording, and link four will be a current batch recording. And give me one second, I can quickly share those links, how the links look like. Course material, the information, and the other one will be, give me one second, I'm going to share that link. Right. If I can share my other window here, right. What I was talking about is the link one. What you can see here in this my screen will be your course materials, where you will be having all the related materials, your PPTs, workbook, ebooks, and some of the extra concepts. Everything will be uploaded on this course materials Google Drive link. And the second link will be other information where you can see all the tools, all the softwares, all the automation scripts, all the interview questions will be available on this second link. And the third link will be your previous batch recordings. We have previous batch recordings. Along with that, we have the associated notepad. If you can open the previous batch recording, you can watch them in a fast track mode or prepare yourself in advance. And also whatever the demonstration I'm doing it in my lab, the notepad will be copied and pasted over here along with the recordings. So the fourth link will be current batch recording. So this is yesterday's demo sessions what we conducted, and this is yesterday's the notepad what command I executed. The output everything will be captured and then uploaded here along with the recording. You can watch the recordings and parallelly you can refer this notepad and you can practice it on your lab. Right. So these are the Google Drive links. You'll be getting access. Give me a second. All right. So these are the Google Drive links. The four links what I just explained. You'll be getting access and will be added to WhatsApp group. The WhatsApp group is basically for all the communication. Google Drive links is for accessing all the materials and all the recordings. And these are like both are lifetime accessible materials and WhatsApp group. And you can keep WhatsApp group active by posting questions, queries. I'll be able to answer all of them. And Google Drive link will be accessible throughout the lifetime. There's no time limit and all. So you can download those materials and recordings to your laptop. No restriction on that. So that is only for dedicated students who are registered for this course. And the course curriculum, course timing, and fee structure, what I just covered. And who are interested, feel free to ping me and my WhatsApp number. I'm gonna paste it here once again on the Zoom chat. You can take a note of that, my WhatsApp number and cell number or email ID. Right. On top of that, what we covered, the minimum requirement for this particular course. You should be knowing the database knowledge first. Without database knowledge, never ever register for this track course because RAC is an advanced course on top of the database course. You should have a prior knowledge on the database course. That's a must. If you're working as a database administrator, DBA, and you know the basics of database, then you should be already knowing this basics of Windows, Linux, and SQL. And if you don't know, also not a big deal. So you will be able to catch up the things and you will be able to understand this Windows, Linux, and SQL basics. But database knowledge is must. You should be knowing your database or Oracle architecture and fundamentals. Then only you can able to catch up this track. So other important thing is hardware requirement. So which is very must required require prerequisites because without this hardware requirement you'll not be able to do a lab setup and you'll not be able to do a hands-on. So you should have minimum 20 GB RAM and minimum 100 GB hard disk, SSD hard disk, so that you can set up your own lab on your laptop or desktop using Oracle VirtualBox. Without this requirement, you will not be able to do a hands-on, you will not be able to do a lab setup. So you should be able to listen whatever I'm teaching and you should be able to see whatever demo I'm doing it. But until unless you don't do hands-on experience, you'll not be able to get the confidence on that particular topic. So one of the must required factor is you have to do hands-on to get and understand that concept completely. get into the bottom of that concept and then get hold of that particular concept will come into picture only once you do a hands-on. So to do that hands-on, you should have the minimum required hard disk, like hardware requirement, RAM and your SSD storage, so that you can set up your lab. Right. So again, we got couple of things yesterday. So I don't have 20 GB RAM. I have 16 GB RAM. Personally, many people are pinged. I have 16 GB RAM. I have 8 GB RAM. I don't have SSD. So what we can do? So there's nothing much we can do if you don't have the hardware requirement. So if you're okay, I don't want to do a lab for now. I still want to continue with the course. So feel free to register for this course. But only thing is you have to regularly attend the classes and then listen what I'm teaching and then prepare your own notes. And whenever you get your hardware requirement and you can do a hands-on lab exercise. That's the only thing you can do it. Otherwise, without hands-on, it will be very, very difficult to remember the things. You can easily forget it. All right. So that's all what we covered yesterday. And then what we're gonna plan to cover today is couple of topics around this rack architecture, networking, and some of the IP addresses. What I'm planning to cover it today. So I'll gonna give 1 or 2 minutes if anyone has any questions so far, or whatever we covered yesterday, or anything related to this particular course. Feel free to unmute yourself, ask any of the question if you have, or you can use the chat window and you can post your questions. I'm gonna take those questions and answer. I think Girish has pinged here. The installation will be done next classing onwards. So this is a demo session. Yesterday and today are just a demo session generally available, and these are like generic ones, so it will not be considered as part of this course. So actual course is going to start next week onwards, and that's where we can start with installation and architecture part. All right. Any questions, guys? If not, then I'll proceed with the some of the fundamentals, some of the basic concept around this rack. All right. I'll take it as a no, and I'll start with the further discussion. Uh, Very first topic I wanted to cover is rack versus standalone. Why rack? So maybe one of the common question in the interview, what are the advantages of rack? Why rack? What are the advantages of rack? Why we need a why all the enterprise customer has to go for rack? So three fundamental difference between your standalone versus rack. One is HA, high availability, and the other one is your load balancing, and the third one is your failover. There are so many other advantages, but three fundamental main difference between your standalone versus rack or rack versus standalone, or why we need a rack and what are the advantages of rack is high availability, load balancing, and failover. So if I can open my PPT here, I do have this slide here. So let's understand a standalone versus rack, what happens. So let's say, again, this is a three-tier architecture, the front end, middle tier, and the back end. Back end is the one where we DBA work on the database layer, on the databases here. The front end is your application developer, and middleware is the apps team will be setting up. So we'll not be working on these two areas. And if you are a EBS app DBA, what I was discussing, somebody asked question, right? What is the advantage of EBS app DBA? If you're a EBS app DBA, you'll be working as a DBA, maintaining your backend database, and as a EBS admin, you'll be working on this application part. So you'll be installing this application, you'll be configuring this application, and you'll be taking care of this apps section as well as this database section. If you're a core DBA, then you'll be working on only this backend storage, your database storage here. So you'll not be working on this apps layer. So, but your apps DBA or OBI DBA or your PeopleSoft admin or SOA admin, then you'll be working on this middleware as well as this backend tier. Right. So if it is a standalone, what happens? So let's say you got around 1,000 connections, like around 300 connections from here, 300 connections from here, 300 and 400 connections from here. Some people are using from URL, web URL to connect to database. Some people are using mobile application. Some people are using desktop client to connect to my database. All will go to your application server. From application server, connection will go to a single host here. This is your single host or Linux server, and you will be having only one single instance. In case of your host disconnected or your host goes down, or in case of your instance goes down, you will not be able to access your database. So it's a complete downtime. And then this particular Linux server or the host will not be able to handle these 1,000 connections, right? So that is major drawback with a standalone. Whereas in case of rack, let's assume same 1,000 connections are coming here, and then 300 coming from URL, and then 300 coming from mobile device, and 400 coming from desktop. All will go to your application server. From app server, all the connection will go 300 here, 300 here, 400 here. So we have this Linux server 1, Linux server 2, Linux server 3. The very first thing is your high availability. The first advantage what I talked is high availability, meaning here one single Linux server is unable to handle your 300 connections, whereas we have three servers. The load is equally distributed, and at the same time, if one of the server goes down, you have another two more servers. Let's say you have another 100 connections are coming in. The connections will go to either node 2 or node 3, any of these two. In case of this server 1 is not available, we have another two more server, high availability. In case of standalone, if one server is not available, it's a complete downtime. There is no high availability for any of the incoming connections. So in case of rack, we have this high availability. One server is not available. We have another server which is up and running. Connections will go to that new server. That's the meaning of high availability. The load balancing, if there's 1,000 connections are coming, my rack or the cluster where is smart enough to distribute those connections evenly across all the cluster nodes. That is your load balancing. And the failover, let's say you have 300 connections are connected to this one host, and if this particular host goes down or this instance goes down, all these 300 connections who are connected to this instance one will go to your second instance and will go to this third instance. So maybe around 150 connections will go here, 150 connections will go here based upon the load balancing. The failover will be achieved. Whatever the user connected here, all will be rerouted to other available instances. That is your failover. All these three main features, high availability, meaning one server is not available, you have another server to support that incoming connection. Load balancing, whatever the incoming connections, 1,000, 2,000, 3,000 are evenly distributed, equally distributed across all the cluster nodes. Failover, if the already connected users on a server, in case of that server goes down or the cluster goes down in that server or that host, all those connected users will be automatically failed over to your other available cluster instances or cluster nodes or the cluster host. So these are the three main advantages why we need to go for the rack rather than the standalone. Right. And then there will be other couple of questions around this load balancing. I said load balancing. So in this load balancing, who is responsible for load balancing? So couple of questions you may get in the interview. Who is responsible for load balancing? So we typically know scan. Scan is responsible for load balancing. And then again, there will be a couple of questions. What is scan? How scan is able to perform load balancing? How scan is able to identify the load of a server? How many users are connected? What's the load on the server? It's all about scan functionality, how scan works, and what is scan, and then how many IPs scan has. Is scan has 1 IP, 2 IP, 3 IP, 4 IP, 10 IP, 20 IP, and is scan VIP or physical IP? Right. So whatever I talked about load balancing, in the load balancing itself, you'll be having hundreds of questions. You may get it in the interview. So we are going to cover in details. I'm not going to explain about all this concept. If I try to explain it, it will take another 2 to 3 hours. I'm not going to cover it. But what I'm trying to explain here, just load balancing is not enough to understand the rack. The moment I said load balancing, you should be able to understand scan IPs, scan VIPs, and how scan is able to do a load balancing. How can I verify whether the scan equally distributing the load, whether my scan is working or not, and what are the scan names, what are the scan VIPs, what are the scan listeners. So many things will come into picture. All will together clubbed and able to perform this load balancing. And again, in depth, if you go, what is scan, how is scan able to do a load balancing, how scan is able to identify what's the cluster or what's the node, the load, and how much user connected and all, how scan is able to identify all those is internal concept. We're going to cover it in detail. And then I said about high availability. So high availability meaning, let's say if one node is not available, so let's say right now I have 3 nodes, I got a 3 connections. If I got a 3 connections, connection 1 will go here, connection 2, the second user will go here, and connection 3 will go here. In case of one server is not available, fourth connection comes. Fourth connection will go either node 2 or node 3. The fourth connection will never go to node 1 in case of node 1 goes down. How my cluster is able to identify this node 1 is available or not? The end user can connect to any one of the node. By how end user connection will know that whether node 1 is available or not? How the end user should be able to connect? Again, for that, your scan will come into picture. Your scan will come into picture, and scan will able to do this high availability. So it's a client side connection high availability. And also why we need to have 3 IPs for scan. So why we need to have a 3 IPs for scan? For the client side connection high availability. For that, we should have 3 IPs for the scan. Not only 3, you can have 4, 5, 6, 7, 8, doesn't matter, but 3 is the default one. So that is one of the, again, sub questions you can get it on the high availability. And again, failovers, why we need VIP. We have something called VIP. So on what basis we're able to achieve this? Like, user 1 is connected here on this instance 1, and user 2 is connected here on instance 2 or the server 2, and user 3 is connected here on this host 3 or server 3 or the instance 3. If the instance 1 goes down or the cluster goes down on host 1 or the Linux server 1, all this connected user will go to either instance 2 or either instance 3. How this connection is able to fail over to the other instance. That is because of a VIP. So why this VIP we have needed? To achieve this failover. Without this VIP, we will not be able to do this failover. And then we are talking about failover. What all transactions are supported for failover? Like your DML, DDL, TCL, or so many things. Like if you talk about SQL statement, it may be DML, DDL, or TCL, or select query. So what all the failovers are supported? RAC supports only select query failover. No DML, no DDL, no TCL. These query failovers are not supported. Only select query failover is supported. For example, a user 1 is connected to instance 1, is reading around 10K records. Out of 10K records, he already read select star from employee. It is fetching 10K records. 5K records are already he fetched it, and another 5K record he has to fetch. This instance goes down automatically. His connection will go over here, and then he's going to start it from 5001. Remaining 5K instance, 5K records will be fetched from here. That's the select query failover is supported. For example, DML query, insert query. He is doing an insert. He is inserting same thing like user 2 is connected here, and then he is doing some 10K record insertion. Out of that 5K record he is inserted. Remaining 5K record he has to insert. This instance goes down. His connection will go to second, third instance here. And then whatever this 5K record he inserted, all will be rolled back. And he has to freshly start that 10K record insertion again. So that is your DML transaction. DML transactions is not supported in case of a failover. So remember that might be your one of the questions. Is the DML query or insert query or delete query supported for the failover? No. RAC supports only the select query failover. Only the select statement will continue from where it has failed. Other than that, insert, update, delete, the user has to re-execute that query again. All right. So that is a very first concept. What I wanted to cover it, some of the basics points. Why RAC? What are the advantages of RAC? And then what's the difference between standalone and RAC? And these are the three main advantages. Other than that, we have high speed read write in ASM disk, and your ASM mirroring and other concept will come into picture, but those are the not that important when it comes to RAC. But when it comes to RAC, it will be high availability, failover, and load balancing. Right. So let's explore any questions so far. I will take 1 or 2 minutes if anyone has any questions so far.
Hi, Malay. Good morning. We have the VIP, right? And if we have the load balancing option equal to yes, then the VIP itself will do the load balancing as like the scan
No,
IP.
no. VIPs are different and load balancing is different. As I told, VIP is meant for your failover, not for the load balancing.
But in one of our client side, they have a TNS name and they have the VIP entries and they have the load balancing option equal to yes.
No, that's not gonna work.
Okay.
Just a traditional method. It's a traditional saying. If you mention load balancing equal to yes, it's gonna do a load balancing, but it's not gonna do load balancing.
But it will switch the connection, right?
No,
Malik, like 3 VIPs, it will give 1 VIP at a time and another at another time.
no,
Not like
no. The concept is totally wrong.
okay.
Yeah. So we'll cover that in details when we actually start the class. That time I can explain you how that failure happens. And in the TNS, whatever they mention load balancing equal to yes, it's meaningless. It's useless. The load
Okay.
balancing will be
Thank you.
done by scan.
Okay.
Right. So there's a question in the chat: how DML failure is possible in RAC? Yes, there's a possibility of DML. We have a 19C new feature called TAC, Transparent Application Continuity. With help of TAC, That's a new feature in 19C. If you enable that tag, and again to configure the tag, it's not that easy. You have to execute a 20 or 20, 30 steps. You have to configure tag, transparent application continuity. With help of tag, then you can achieve this DML failover. The TML transactions, you can handle that failover. And another question, TAP comes into picture. TAP is nothing but transparent application failover. Whatever I explained here, failover, it's a TAP, transparent application failover. Some people will call it as a just failover. Some people will call it as a TAP, transparent application failover. All right. Let's talk about, since we talked about a couple of IPs here, a scan IPs, let's put it as A, B, and C. So let's say this I can make it as a concept 1, rack versus standalone. I'll make it as a 2. Some of the networking, VIPs or public IPs, private IPs, and scan IPs. So one of the common questions in most of the interview, in order to set up 2-node rack, how many IPs are needed? What are those IPs? So in simple definition, in order to do this, a 2-node rack setup, the very first thing I need are 2 physical IPs. The requirement for the IP addresses are, let's explain here. So I need 2 hosts, let's say 2 hosts needed. This is a 2-node rack setup, what I'm doing. I need 2 hosts. And for those 2 hosts, let's say Oracle Lab 1 and Oracle Lab 2. For that, I need 2 physical IPs. I need 2 VIPs. And I need 2 private IPs for those hosts. Whatever these 2 Linux servers, what I'm using it and doing this rack cluster, 2-node rack cluster. Both this node, Oracle Lab 1 and Oracle Lab 2, should have 1 physical IP, 1 VIP, 1 private IP. Here itself, I need 6 IPs. And then, in order to support your load balancing, we should have scan. And then one scan can have 1 IP or 2 IP or 3 IP, or you can go with ETC. Like, the scan, you can configure a scan with a 1 single IP, or you can configure a scan with a 2 IPs, or you can configure a scan with a 3 IPs. So default, I'll go with the default definition. Default scan will have 3 IPs. So I'll go with the default option. So in order to do a 2-node rack setup, I should have 2 physical IP, 2 VIPs, 2 private IPs, and 3 scan IPs. A single scan, 1 scan can have 3 IPs. So altogether, I need 6 IPs for including physical, VIP, and private IPs, and 3 IPs for scan. Totally, I need 9 IPs to do a 2-node rack setup. Again, considering scan as a default 3 IPs. Nobody is stopping you. You can go with a 1 IP, 2 IP, 3 IP, 4 IP for scan. Doesn't matter, everything works. But again, question comes, why 3 IPs for scan? Again, we're going to cover in our regular classes. Why 3 IPs or multiple IPs for scan? So that's the internal one. We're going to cover it in our regular classes. But in order to answer this question, in order to do a 2-node rack setup, I need minimum 6 IPs for those 2 nodes, and I need default 3 IPs for scan. Totally, I need a 9 IPs. The IPs go like this. course names, Oracle Lab 1, Oracle Lab 2, localdomain.com. Physical IP, let's say 192.168.1.101, 102. VIPs 103, 104, and private IPs 2 dot series. If you observe here, this is a 1 dot series and this is a 2 dot series, the private IPs. So 101 and 102, but it's a different network or the subnet private IPs. And the scan IPs default is 3, and again that will be in the same range. So it will be goes in this format: 101, 102, 103, 104, and I'll go with 105, 106, and 107. So that's a pretty much IP is what I need. So again, there'll be a couple of questions. What is physical IP? What is VIP? What is CAN IP? What is private IP? So those are again fundamental understanding. Physical IP, VIP, scan IP, private IP. Again, we'll go in depth analysis and understanding in our regular classes. But if I want to tell in simple definition why we need this physical IP, why is physical IP and VIPs are same? Again, couple of questions if I add to this one. Is physical IP and VIP are in the same network? By looking at this one here, physical IP 1 dot series, VIP 1 dot series. Answer to this question is physical IP and VIPs are in the same network? Yes, they are in the same network. If you look at this 1 dot series, they're in the 1 dot series. Is physical IP and scan IPs are in the same network? Again, scan IP, if you see here, 1 dot series, and my physical IPs are 1 dot series. So yes, they are in the same network. Is VIP and scan IPs in the same network? If I look at VIPs, again 1 dot series, and my scan is also 1 dot series. Yes, they are in the same network. Is scan IP, is scan is a VIP or the physical IP? Right? Like scan is a VIP, virtual IP. Again, if you understand what is physical IP and virtual IP, then you can easily understand what is scan. Scan is a VIP. Scan is made up of VIP address, not the physical IP. So VIP in simple definition, VIP does not have any interface, and physical IP have interface. I'm just giving interface as example. Interface meaning your ETH0, ETH1, ENSP, S0, or ENSP, S1. Like based upon the different Linux flavors, you can see these interfaces. So if I can show here in my labs, do I have a lab opened? No, let me open my lab. Lab. Right. If I go here on one of my lab here, ifconfig. So whatever we are seeing here, ENS 192 and ENS 224, these are the interfaces. If you do it near any of the client machine, you can see bond 0, bond 1, ETH0, ETH1, all those things. Those are called interfaces. Right. So is a scan and scan is a VIP or a physical IP? Answer is scan is always VIP, not a physical IP. And again, definition for the physical IP and VIP. Physical IPs are nothing but the IP assigned to interface is called a physical IP. VIP IP does not have any interface or does not assign to any interface is called a VIP. It will be just floating. And again, scan IP, scan is a VIP, similar to your VIP IP address. And again, VIP has a different purpose and scan has a different purpose. And what is private IP? Again, IP, private IP is nothing but a physical IP. A private IP is nothing but a physical IP, but in the different subnet. If you see here, a private IP is 2 dot series. The subnet is 2 dot, different network. And physical IP is 1 dot series. Your physical IP is associated to interface. Similarly, your private IP is also a physical IP, meaning private IP also associated to an interface, but it's in a different network. Now the question comes, why private IP is in different network? Why can't in the same network of a physical IP? Right, so that is again underlining common question in the interview. Why private IP is in a different network? Since your physical IP and private IP both are one and same, both are physical IPs associated to interface, why we should put our private IP into a different network? What's the reason behind that? So the reason, the simple definition, it is heavily used. The answer to this question is a private IP is heavily used. Because of that, private IP is heavily used or more used. One of the reasons. What are the use cases of this private network? Your network heartbeat, your disk heartbeat, and your cache fusion. So these are like most of the activities which happens in your private network is your network heartbeat check, disk heartbeat check, and cache fusion activity, and your cluster communication. All will happen to this private network. And this is because of this heavy activity, we don't want to put all these activities in the physical IPs or the physical network. So your physical IPs, your physical IPs or VIPs or your scan IPs are meant for client connection and client transaction. So whatever this physical IP, VIP and scan IPs are all on the same network. If I go back here, my physical IP is 1 dot series, my VIP is 1 dot series, my scan IP is again 1 dot series. All of them are in a single network. All these physical IP, private IPs, physical IP, VIP and scan IPs are meant for client connections or the client transactions. Whatever the client, whoever the client is connecting from the different application, they should have a dedicated network to do that query transactions more efficiently and very faster manner. Because of that, we should go with a different network so that we can differentiate our cluster intercommunications or cluster communications or the disk heartbeat or the network heartbeat or the cache fusion into a different network so that we can get a dedicated network for my client transactions. So if I can go both private IP and our physical IP and CAN IPs and VIPs into one network, so all this cluster communication will impact my client transactions. My client queries or transactions will not get a sufficient network bandwidth because entire network bandwidth will be used for my cluster communication. So to avoid that, the Oracle has divided these two different networks. All right. So that is, we started with the definition of how many IPs are needed, and we end up with multiple IPs. And what are the advantages and what are the use cases of all of these IPs. So if I can further go for real definition here. So whatever I just given that IP addresses or look like this. I have this node 1, the Linux server 1, I have this Linux server 2. And then I have installed my ASM or the clusterware or the grid infrastructure. On top of that, I have created this DavidDB instance 1 and DavidDB instance 2. And all of them are pointing to a shared ASM disk group here. My actual database is residing over here. So both the node 1 and node 2 has physical IPs and VIPs and then a private IPs. And if you observe private IP, I made it in a red color with a 2 dot series. Remaining all a physical IP, node VIP, and scan VIP. All of them I made it to the green color. All of them are into 1 dot series here. Right. So whatever this green color is called a public network, means publicly accessible. All client can able to connect to my database using this public network. Whatever this red color here are private network, which is accessible within your organization. They cannot be accessed outside of your organization. Whereas public network, you can access it outside of your organization, whatever the domain. So now let's say assume client is trying to connect to my DavidDB database. The client connection will first go to scan. Via scan, scan is smart enough or scan is intelligent enough to route that connection to either node 1 or node 2. If the connection goes to node 1, you will be connecting to instance 1. If the connection go to node 2, will be connected to instance 2, DavidDB instance 2. And then finally they'll end up with accessing the same database which is connected on your shared storage or the ASM disk group. Right, that is a simple definition how IPs are needed and how IPs are used. And again, in real time, why we need these multiple IPs for the client connection high availability and how the scan is going to route this connection and how the failure will be achieved. So the actual fact when you talk about simple definition, client will connect to scan, scan will route the connection to either node 1 or either node 2. That's not that simple. The connection will go like this. The client 1 will connect to scan, scan will decide to go to either node 1 or node 2. Once it decided to go to node 1, then scan will go to that VIP, via VIP, it's going to connect to your database instance 1. In case of this node goes down, and automatically this VIP will fail over to here, 103. The moment this VIP will fail over here, this client connection who are connected to this instance 1, all the connections will come over here. So that's the advantage of VIP. Why scan route the connection to VIP, via VIP, the client is able to connect to my database. If the client is connected via physical IP and then connected to this database, the moment the server goes down, this physical IP will go down because the physical IP definition is this is assigned to interface. If the server goes down, cluster goes down, this interface will go down. So this physical IP will go down. The moment the physical IP goes down, the client client connection will not be able to fail over. So client has to connect from the scan has to route that connection to VIP so that this VIP will fail over to your other cluster nodes. So just to show you that in a quick demo here, so I'm going to set the environment to plus ASM1 env grep capital Aura. If I do crctl stat resource -t on this node 1, I have this scan 1, scan 2, scan 3. I have 3 scans. Scan 1 is running on node 1. Scan 2, scan 3 running on node 2. And then the VIPs of the associated node 1 VIP, node 2 VIP. Node 1 VIP running on node 1, node 2 VIP running on node 2. The moment I shut down node 1, what happens here? Let's say we have this physical IP1 and we have this physical IP2 and we have this VIP1 and we have this VIP2. And then out of this 3 scan here, scan 1, 2 and 3. So scan 1 is running under node 1, 2 and 3 are running under node 2. So it will go like this. My scan 1 is running over here and my scan 2 and my scan 3 will be running here. So I talked about scan 1 is a VIP and scan 2 and 3 again VIP. And my node 1 VIP is again VIP and my node 2 VIP is again VIP. So these VIPs does not have any interface. The moment this cluster goes down here, the scan will run over here and this VIP will run over here. That's called failover. Right? I can go to second node. I can set the environment to ASM2 plus ASM2. I'll run the same crctl stat resource -t. Same thing here. My scan 1 running under node 1, my node 1 VIP running under node 1. The moment I shut down my cluster here, crctl, I'm not going to reboot the node, but I'm going to just stop my cluster. The moment I stop my cluster, all these VIPs, my scan 1 VIP running under node 1 will fail over to your second node. My node 1 VIP running under node 1 will fail over to your second node. Right, you can see scan 1, scan 2, scan 3 all are running under node 2 now. And my node 1 VIP online intermediate running under node 2, which is failed over. So that is the advantages why client connections goes to VIP. To achieve that failover, the VIPs are must. So that's what our definition here. Very first, what we did, why rack, what are the advantages of rack? I talked about this failover. So why we need a VIPs? What all transactions are supported for failover? So why we need VIP? That's the answer to that question. Without VIP, we'll not be able to achieve this failover. If the client connections connected via physical IP, the client connections will be broken or disconnected. There won't be any failover possibilities with the physical IPs. Only VIP can support that. All right. So I'll take a pause or a minute here if anyone has any questions so far on the IPs.
Hi Malik. As we have 3 scan, and in case of more number of nodes, like 5 nodes, so we'll have 5 VIPs, but there will be only 3 scan IPs, right?
No,
So
five VIPs, 5 scan IPs. How many IPs you can have it per scan? Those many VIPs.
okay, I
Right
mean we'll have
now in my definition here, I defined scan with the 3 IPs, and because of that I can see 3 scan VIPs and associated, there's a three scan listeners here. Scan 1, scan 2, scan 3. There are three scan listeners which will be started with those three scan VIPs because my scan is made up of three IPs. If you configure your scan with the five IPs, there will be five VIPs and five scan listeners, and they will be running on any of the cluster node.
Okay. Okay. Thanks.
All right.
Hi, Malik. Let's say we have four nodes and we have only three VIPs, three scan IPs.
Yep.
So the node 4 will be unused, right? Because each node has
Not
one
unused.
scan.
Your scan has to run on anywhere. The scan
But what?
process has to run anywhere. It may be node 1 or node 2, node 3. If you mean like I have four node, my connection will go to only three node, not like that. Like if I have four node rack, my scan 1 will be running here, scan 2 will be running here, scan 3 will be running here. These are the process or service running to support your scan. But it doesn't mean that all the connection will go to only 1 and 2 and 3. This node 4 will not go any connection, not like that. You have to think, you have to visualize in this particular format. Your scan will be a floating one. It can run anywhere, but can route that connection to either node 1, node 2, node 3, or node 4. Your scan may be running here, scan may be running here, or your scan may be running here. But the client connection comes, client 1 comes, will go to node 1. Client 2 comes, will go to node 2. Client 3 comes, will go to node 3. Sorry, node 3 is here. And client 4 comes, the connection will go to node 4. The service can run any of the cluster node. It may be node 1, node 2, or node 4. Or it may be node 1, node 2, and node 3. So the scan based upon your IPs can run any of the cluster node. That doesn't mean that connection only will go under that particular node where the scan is running. Those are the process to support your scan functionality. It can run on any of the cluster node.
And one more thing, Malik, sorry to disturb. If the scan is able to route to a VIP, for example, we have only three scan IPs and we have four nodes. So the scan one receive the connection and it will look for the less loaded node. For example, if the node 4 is lessly loaded, then it will call the node 4 VIP and it will redistribute the connection. Am I right, Malik?
Right, right.
Okay.
Again, this is not just is gonna take that node 4 and reroute it. There's a listener comes into picture. We have multiple listeners. We
Okay.
have scan listener, we have local listener, we have remote listener, we have grid listener, we have ASM listener, we have ASM net listener. So these all listeners will communicate each other and then route the connection. It's not just like scan is going to go to fourth node and route the connection. Based upon the listener configuration, it will take a decision. So we'll talk about listeners and all in our actual classes, how the scan is going to route the connection.
Thank
But
you,
yeah,
Malik.
to answer your question, it's right. Whatever it says, scan will identify least loaded node, that's a node 4, and then route the connection. But behind the scene, your listener will come into picture.
Thank you, Malik.
So is that the scan underscore, we have the green box at the top? Is that the configuration done in DNS server?
Right, right. That's correct.
Okay. So if we have four nodes, so we'll have four IPs added in DNS server, right?
For the scan,
I mean in the DNS setup, what we'll have if we have four nodes?
these all
Us,
IPs are defined in DNS.
okay.
All these IPs. Your physical IP, private
For
IP, your VIP, scan IPs. If you're running with a 2-node rack, 3-node rack, 4-node rack, all IPs will be defined in DNS.
I was little, I mean, I understand for physical IPs and VIPs. I was confused about the scan IP. So how many scan IPs required for if to set up in DNS for four nodes?
Again, default is 3. You can run your scan with one IP only. You can configure only one IP for scan. Nobody is stopping you. You can go with a 2 IP, 3 IP, 4 IPs. Nobody is stopping you.
Okay, so with three we can run four or five nodes, so that should be okay, right?
Yes.
That was okay.
Again, there's no thumb rule for scan. With a one scan IP, you can run your 4-node rack cluster, 5-node rack cluster, 8-node rack cluster, 10-node rack cluster.
Okay, so every time client is trying to connect, it will actually in a round robin, it will get one scan IP from the DNS, right?
Again, that's a different story. Why we need 3 scan IPs? Why we need 4 scan IPs? Why we need 5 scan IPs? That is called your high availability for the client connection.
Okay.
I explained here. Again,
Okay.
scan will come into picture. Client side connection, high availability. We need multiple scan IPs. Again, at this point, you'll not be able to understand why high availability, what is client side connection, why we need 3 scan IPs. We'll cover in detail about our regular classes. But to answer to your question, there's no thumb rule, that there's no definition. You can run your scan with a 1 IP also. You can run your scan with a 2 IP, 3 IP, 4 IP. Doesn't matter. And all these IP should be defined on your DNS server. All right. So that's about your all the IPs requirements and all the client connections and how the failover is going to happen in case of node goes down or cluster goes down, and then how the transactions will be failed over to existing nodes.
Yeah, Malik, I have one doubt regarding whenever I have seen the in first node, it is showing online virtual IP status. When it comes to down the virtual IP in node 1, in node 2 it is showing intermediate state.
Right.
What is the difference between the online and intermediate?
Again, we'll cover in detail about what is online intermediate, what is failed over, what is stable. That is your, that if you go up here, it's going to tell target status and what's the current state.
Okay.
Right. Again, we'll discuss in detail. Just for simple definition, whether target meaning whether that resource is configured on that node or not, and status meaning what is the current state of that particular resource. So this is target, whether it is configured or not.
Okay.
That's the status of that resource, whether the resource is running or whether the resource is not running. So it will be either offline or online or intermediate. Only 3 states you can see it here. And again, we'll discuss in further regular classes why intermediate. Intermediate meaning it's not going to take any more connections. Whatever the existing connection, it will be routed, but it's not going to take any more new connections.
Okay, sir. Thank you.
All right. So now let's go with the third concept. In simple understanding, you want to talk about rack architecture. We'll go with this particular overview here. So client can connect to any mode, mobile, URL, internet, or desktop, any connection. The connection will go to app server. From the app server, we'll be using a scan connection. From the scan connection, the connection will go to any of the node. Node 1, node 2, node 3, node 4. And all of these nodes will be having a physical IP. And then all of these nodes will be having a private IP. And then this scan, whatever we're reaching at application server side, will be having a scan 200, 300, 400. I'm just giving random, like there's nothing called IP 400, but just to simplicity, I'm giving these 3 IPs 200, 300, 400. And based upon that, the wherever client is connected, he will be able to access the database which is reside under shared storage. And then he'll be able to do his transactions. And then for all of this node 1 and node 2, and node 2 and node 3, and node 3 and node 4, or node 4 and node 1, all will communicate each other with a private IP address 192.168.2 series. So this private network is for node to node communication, or from node to voting disk communication. That's the network heartbeat and the disk heartbeat. And from buffer cache to buffer cache fusion. Because of that reason, we have a separate network for that private connection. So if you're able to explain all these IPs and you're able to explain all these client connections, and your advantages of rack, high availability and failure and load balancing. That's more than enough for any of the interview. Like whatever else, can you brief about the rack concept or the rack architecture or rack connection? So if you're able to brief this one, that's more than enough. But in reality, if you talk about real in-depth knowledge or understanding of rack, this IP is not enough. We have hundreds of services or the daemon or processes, so we should be able to explain all of them. For example, this is your actual rack, a daemon or the rack clusterware resources, how the startup sequence works when it comes to reality. So again, to remember all of these resources, it's not that possible. Right, now what I'm going to do, I'm going to quickly talk about, before I go with this architecture part, let's go with the installation part. So how this rack setup will be done? And then what are the different naming convention many people will call it as? So these are the different names: grid infrastructure or ASM software or clusterware software. With help of this software, this is one and same. Some people will say GI software or grid infrastructure software, ASM software or clusterware software. These all one and same, single software. With help of this software, we are going to install GI home or ASM home or clusterware home. These are like one and same. With help of this software, we're going to install this home or the binaries for that. Once you download this software and unzip, that will be your grid home or ASM or clusterware home. One and same. Many people will call all these 6 different names, but all are referring to one and same. Same thing goes for your Oracle software as well. Many people will call it as the Oracle software or database software or rack home, rack Oracle home. All are referring to one and same. With help of this software, I'll be installing Oracle home or database home or rack software or rack home. All are referring to Oracle software. So again, it's based upon which name you are familiar, you're going to call it out. So for my clusterware installation, what I'm going to do, the GI, grid infrastructure installation or ASM installation or clusterware installation, one and same. I'm going to download this 19C GI or ASM or clusterware software on Node 1. I'll download this software on Node 1 and I'm going to unzip that 19C software into use your own app 19C grid and run grid setup.sh. It will ask you to enter IPs, that's your physical IPs, and VIPs, and CAN details. Once you enter your physical IPs, both the physical IPs, both the VIPs, and the scan details, it will start ASM instance on Node 1, or it's going to copy, it will copy first ASM or GI software from Node 1 to Node 2 and start ASM SM2 instances. Again, in the backend, it's going to do all the cluster settings and all. So that's the simple definition how this GI installation works. It's your Node 1 and this is your node 2. And then here you'll be running your ASM1, and here you'll be running your plus ASM2. Same thing, once you're done with the GI installation, you'll proceed with your Oracle Home installation. You can call it as the Oracle Home, Database Home, and RAC Home. All are referring to one and same. Same thing, we're going to do download 19C Oracle Home and Database Home software on node 1. Unzip that 19C Oracle Home and Database software, Oracle software, or Oracle or database software into whatever the home you're going to define. These are the standard naming conventions. You can define it wherever convenient name, and run installer. We're going to run the run installer. Here we're going to run the grid setup data set. We're going to run this run installer. Now it will show all the rack nodes, whatever the rack node we have selected, whatever the rack cluster nodes we formed here, node 1 and node 2. It will show all the rack nodes, and then we are going to select all the rack nodes. We are going to do checkbox on all the nodes. And then it will copy, it will set up your node 1, the Oracle Home on node 1, and then you're going to copy that Oracle Home into your another node, node 2, node 3, node 4. And then your rack setup will be done. Your Oracle Home setup will be done. So you will be having your grid first here. Earlier we installed this grid and ASM, and now we installed Oracle Home here. And once the grid home is done, once Oracle Home is done, then third step, database creation. We're going to connect to node 1 and go to Oracle Home and bin. So we'll connect to node 1 and go to Oracle Home and bin, and then run /DBCA, database configuration assistance. Once you run the DBCA, it will ask all the database details like name, SID, SGA, PGA, and data file, location, FRA. The moment we run the DBCA, it will ask all the details. I'm going to pass all these details, and then it's going to set up your RAC database. Let's say the RAC database here will be formed. Give me a second. Let's say I have 4 node rack. This first node here. Right, if you look at here, the grid infrastructure, I need to give this all the VIPs, physical IPs, private IPs. I given this all the 4 node IPs, my ASM1, ASM2, ASM1, ASM2, ASM3, ASM4. 4 node rack cluster is started here, real application cluster is started. But at the time of Oracle Home installation, you're going to download the database software on node 1 here, and you're going to unzip that one. Once you unzip, you're going to run this run installer. Once you run the run installer, it will show all the rack nodes. It will show you node 1, node 2, node 3, node 4. And you have to checkbox. You have to select all those 4 nodes and install it. Then only your Oracle Home will install on all the nodes. After that, you can run the DBCA. Automatically, your database will be created on database 1, database 2, database instance 3, database instance 4. All the 4 node rack database will be created. By mistakenly or by purposefully, you run this uninstaller and it will show you all the rack nodes, node 1, 2, 3, 4, and you selected only node 1 and 2, and you have not selected these 3 nodes. And your Oracle Home, second Oracle Home created only on 1 and 2. These 3 and 4 are not created. There's no Oracle Home here. And later you can run this DBCA, and then your database will be created only testdb instance 1, testdb instance 2. Only 2 node rack database will be created because we have installed only 2 node rack Oracle Home. Here we installed 4 node rack Oracle Home, and my database, whatever I create, it will be 4 node rack database. Here only 2 node Oracle Home. Your database instance will be only 2 nodes. So that's all customization you can do it at the time of your Oracle software installation based upon how many nodes, how many servers you installed your Oracle software, those many database instance will be get started. All right. So that is for the time of database creation. As I talked yesterday, rack database has 2 types of databases. One is actual rack database. Other one is your rack 1 node. Rack 1 node is, as I talked here, let's say, if I run the DBCA from this particular Oracle Home 1, I can create this rack database 1, 2, 3, D1, D2, D3, D4, or I can go with this D1 underscore 1, D underscore 1, D underscore 2, and D underscore 3, and D underscore 4. It's a rack 1 node. So at any given time, even though it's a rack Oracle Home, only one instance will be running for the rack 1 node database. The name itself says it's the 1 node. So once I shut down this D underscore 1, automatically D underscore 2 or D underscore 3 or D underscore 4 will be get started. At any given time, given single point of time, only one instance will be running. That's the beauty of rack 1 node. While running this DBCA, I run it from this Oracle Home 2, and if I create this rack 1 node, it will be T underscore 1 and T underscore 2. Only 2 instances will be configured on 1 and 2, and any one will be running. T underscore 1 will be running. If T underscore 1 will goes down, automatically T underscore 2 will be get started. So those are the 2 types of rack databases. One is a real rack database, which will be running, all the instances will be running on all the nodes. And in rack 1 node, only one instance will be running at any given point of time. Right, so now, once we understood about the installation part here, the clusterware, the rack setup, and the Oracle Home setup, and the database creation. At the time of database creation, you have option to choose whether rack database or rack 1 node database. And plus this installation, in order to understand this rack concept, rack architecture, we should understand installation. Whatever I just talked about, that's a installation. You have to understand that rack first, and we should understand the IPs, whatever the various IPs what we discussed. We should understand the cluster resources and daemons. The cluster resources and the daemons all together will be able to make you a strong foundation on this rack architecture. So in simple definition, to define this rack architecture, so if I go with the 2-node rack, I have node 1 and I have node 2, and both of this node 1 and node 2 will be having OHASD, Oracle High Availability Service Daemon. That's a core fundamental service on each node it will be running. On top of this OHSD, your a cluster CRS will be running. So OHSD will be core fundamental process on each node, and this CRS is communicate each other, the cluster ready service, which is very, very important to make this 2-node rack cluster. And on top of the CRS, your ASM1, on top of this CRS, your ASM2 will be running. On top of this ASM, your database instance 1, on top of this ASM2, your database instance 2 will be running. If I do shutdown and startup of this database instance 1 and database instance 2, nothing is going to impact. Your ASM, CRS, and OHSD will be up and running. If I do shut down this ASM1, your database 1 will be gone, instance 1 will be gone. If I do shut down this ASM2, your database instance 2 will be gone. If I do shut down this CRS on node 1, your ASM will be gone, your database instance will be gone on node 1. If I shut down this CRS on node 2, your ASM instance 2 will be gone, your database instance 2 will be gone. If I shut down this OHSD on node 1, your CRS will be gone, your ASM will be gone, your database will be gone. It will be all node specific. Same thing if I shut down my OHSD on node 2, my CRS will be gone, my ASM will be gone, my database will be gone. That's what we did here on this node 1. I did CRS-ETL stop CRS. I did a stop CRS on node 1, and it has shut down everything, including ASM, including database, listeners, all the services, everything will be down on the node 1. So this is your high level simple definition or hierarchy, how we can explain about rack architecture. And if you go in deeper analysis, you have to explain about the networking, you have to explain about your IPs, you have to explain about the cluster resource and the daemons. And once you're able to brief this, that's more than enough. Right. Any questions so far on the installation part or the IPs or the resource or the type of databases? Right. Quickly, we can talk about one more concept and then we can wrap it up for today. The file system one. Again, by this time, you all will be aware the basic architecture of our rack, our normal database. So in any database architecture, let's talk about, you should have any database we talk about, instance plus database. Instance and database will form your entire database architecture. Again, your instance is your memory plus BG process. In memory, it comes HGA plus PGA. In background process, it comes a mandatory background process, BG process plus non-mandatory BG process. And that's about the instance. And for the database, we'll have all the data files. That's a simple database architecture definition. Simple database architecture can be defined, the instance and database, and the instance is memory and background process, and background process are mandatory and non-mandatory, and memory is your HG and PG, and database is your data files. So any database to run functional, it needs SP file or P file, and followed by it needs control file, and followed by it needs all the data files. Again, in data files, you have system, sysocs, undo, temp, users. And then we have redo logs, redo 1, redo 2, and redo 3. So we need any database to operate SP file and P file. We need a control file. We need a data file. In case of standalone database, it's a single instance is mapped to a single database. Single instance is mapped to single database, and each of these instance or database needs SP file and P file, control file, and data file system, sysoc, undo, user, temp, and redo logs, and alert log, and all the diag logs. But when it comes to rack, and along with this, let's have one more file, password file. But what happens to in case of rack? Like in case of standalone or the single instance, single database, no issues. Right? So it's just one single instance, single database, all of these files belongs to that. But when it comes to rack, what happens here? Let's put them in a diagram or picture view here. I have two node rack, node 1, node 2. I have my ASM1, ASM2. I have my database instance 1, database instance 2. And all of these database are having this group. And your database will be here. D is your database, and database D1 and D2 are the instances. So if I talk about SP file and the P file, so we'll be having SP file, single SP file, which is shared between your instance 1 and instance 2. SP file is shared, and P file will be specific to this instance 1 and specific to this instance 2. You should have your local P file, which is not shared, which is an instance specific. D1 instance has its own P file, D2 instance has its own P file. But whereas SP file, which is shared, which is under ASM disk group, both a D1 and D2 instance can access the single SP file. Same thing goes for your control file. Control file is again shared. Both the D1 instance and D2 have a single set of control file to share. And data files, your system, sysocs, undo, user, temp. So all of these data files are available here. But one drawback or one difference here, your system, sysocs, temp, user, all these 4 data files are single set of data files. All are shared between your D1 and D2 instance. Whereas your undo is not shared. You have under ASM undo data file 1, undo data file 2. Undo data file 1 is for your instance 1, undo data file 2 is for your instance 2. Undo is not shared. Undo is instance specific. Same thing goes for your redo logs. We have redo 1 and redo 2 for my instance 1. We have redo 3 and redo 4 for my instance 2. These redo logs are again not shared. Again, this is going to be one of your interview questions. What all data files are shared for my RAC database? Your system, sysOx, temp users, all other data files are shared between all the instances, whereas your undo data files are not shared. It's the instance specific. And how about redo logs? Redo logs, again, instance specific. Instance 1 and instance 2 has its own redo logs. They cannot write each other. And one more data file comes is archive logs. Is my archive logs are shared? No. Your redo log 1 and redo log 2 will generate respective archive log 1, archive log 2, and redo log 3 and redo log 4 will generate respective archive log 3 and archive log 4. They're again not shared, even though they are in ASM disk group, but both the database 1 and database 2. Database 1 cannot write this archive log 3. Database instance cannot run this archive log 4. Archive logs are again the instance specific. My password file will be here, PW file. This password file will be shared between your both the RAC instances. My alert log and diag logs. My database instance 1, alert log for my database instance 1, that's instance 1 specific. My alert log for my database instance is again the database instance 2 specific. Alert log is not shared, which is available locally on that server, not the ASM file system. The alert logs and the diag logs, trace files, incidence files, diagnostic files, all of them are instance specific, which will be available under their OS storage. Right, so that's the simple definition how we can distinguish all the different file structures. Your alert log, diag logs are not shared. Each of the RAC instance has its own alert log and diag log, and all are available under your OS file system. Your password file is shared, which is available on ASM disk group. Your archive logs are not shared, which is available under ASM disk group. Your redo logs are not shared, which is available under ASM disk group. Your all the data files are shared except your undo. Undo is not shared. Each instance has its own undo, and all of them are available under ASM disk group. Your control files are shared, which is available under ASM disk group. Both instance 1 and instance 2 can access the same control file. Your SP files are shared, which is available under ASM disk group, and your P files are not shared, which is available locally under that file system. That is your RAC database shared versus non-shared file system. Shared versus non-shared files. It may be anything on this. In simple definition, shared one or your SP file, your control files, your data file excluding your undo, and your password files are all shared. In case of non-shared, your P files are not shared, and your data files, only your undo data files are not shared, and your redo logs and archive logs are not shared. That's one definition. And files in OS file system. What all files you can see it under OS? What all files you can see it under your ASM? OS file system, you can see your P file under OS file system. Okay, again, these also will come into picture here. Non-shared. Your alert log, diag log, trace and all comes into non-shared. The files under your OS file system. Your P file is under OS file system, not under ASM. And your control file, these are all under ASM. and your diag log, alert log, all the diagnostic files are all under your OS file system. The files under your ASM file system or ASM storage, all of them, all you can see under ASM except your P file, except your alert log and diag log. So there may be various questions. What all files will be under ASM storage? What all files under OS file system? Is alert log is a common across all the rack instances, all the diag log, trace files, P file? Is it available under ASM? Is it available under ASM file system or local file system? So once you do a hands-on, then you can able to visualize all of them, and you can able to confidently answer where all these files are located and what are shared and what are not shared, how it can be used. All right. So with that, I would like to stop it here, provided if anyone has any questions, any queries so far, or anything related to course curriculum. I'll give it a minute or so.
I think someone asked about Flex ASM on the chat. So are you going to cover that?
Sorry for that. Okay. So what is Flex ASM? Are we going to see? Oh, no, no. Flex ASM will not be covered here.
Is this just a quick question, Malik? Is this being used at widely now, or is just getting started? This is altogether a different
Flex
architecture, right?
Flexes came in 12C, and then I don't think so. Not many people will be used this one. I'm not seen any clients widely using
Okay.
this.
I mean, this may not have that importance at this moment, right?
Yeah. So
Okay.
in definition, in simple understanding what exactly Flex is, what I mentioned, let's say I have 4 node rack clusters. My ASM will be running here, ASM will be running here, ASM will be running here, my ASM will be running here, my database will be running here, database will be running here, and database instance will be running here. 3 and 4. So in order to run this database instance, I should have this ASM instance. The hierarchy what I mentioned is your OHASD, on top of that your CRS, on top of that your ASM, on top of that your database. So in order to run your database, you should have your ASM. What Flex meaning? You shut down your ASM. You run only one ASM, but still you can run your database instances. That's your Flex. Flexibility in ASM. ASM is not a mandatory. If you enable that Flex, without running ASM, you still run your database instance. All these database instance can use this existing ASM and they can function. Your underlying functionality remains same. In order to run your database instance, you should have ASM instance. But with the Flex, you no need to run this ASM instance. It's unnecessarily waste of memory and waste of process or resource. You shut down your ASM instance, still you can run your database instances. Then how this database instance can survive? This database can communicate with this available ASM instance, and then they can up and run without any issue. So for that, to support this Flex ASM, we got one more listener called ASM Net Listener. So that is one of the other interview questions. If I go here, we have this ASM Net Listener. What is this ASM Net Listener? ASM Net Listener is meant for your Flex ASM. So without running ASM, you can run your database. Then how this database will be function without ASM? So this database will communicate to this ASM instance via that net listener, ASM net listener, and then this can be up and running. That's a simple definition if you can answer about Flex. All right. So if no question, let's wrap it up, and we'll continue further in our next weekend. Next Saturday is the one we start our actual class. I will
Hi,
start
Malik.
from the installation. Yeah,
I have
go
a
ahead.
question.
Yeah,
You have said like the archive logs are not shared. So
right.
is it recommended to have the archive log in the archive log destination or in the FRA? And one more question, how FRA is different from the archive log dest? Is it separate and is it have any advantage?
Again, this is not related to RAG. This is the basic understanding. If you know the fundamentals of database, then you should answer yourself. So a simple definition: what is archive log location? So before going to that, what is archive log? So in fundamental definition, whatever the redo log transactions, will copy it as archive logs. That's your archive logs. It's just nothing but a duplicate copy of your redo log is your archive log. Where you are going to store these archive logs? Are you going to store this archive log on local file system? Are you going to store this archive log on your ASM file system? That is your archive log location. So archive log is nothing but copy of your redo logs, and where you are going to store this archive log is nothing but your archive log location. Is that archive log location going to be your FRA? If you put your archive log into FRA, your archive log location is nothing but your FRA location. If you put your archive log into some other location other than FRA, that will be your archive log location, some custom archive log location. Right? And then coming to FRA, FRA is a future fast recovery area. If you enable the FRA, you can place multiple files in that location. FRA is nothing but a location pointing to ASM storage or the file system storage, where you can keep your archive logs into that, where you can keep your backup into that, where you can keep your control file into that, where you can put your flashback logs into that, where you can put your redo logs into that. So FRA is nothing but a location. Archive log is nothing but location. You want to keep all together into a single location, you can put your archive log location to FRA. You want to differentiate your FRA into archive log location to two different locations, you can define your archive log location to some custom location. You can define your FRA into some custom location. Both are nothing but locations.
Yeah, Malik, my question is why it got the name fast recovery area? So it will recover fast if we put the backups in that location. Something like that I'm asking.
No, nothing about that.
Okay, it's just
Wherever you
a
can say.
okay.
You can keep your backup wherever you want.
Okay, because it names like the fast recovery area. I thought if we put
Earlier,
the backup here,
earlier in prior to 10G, it was called flash recovery area. And later they removed that name and they made it as a fast recovery area.
okay, so there is no advantage of having an FRA. Just it's like a central repository to have all the control files and archive logs.
Right.
Nothing other than that, right? Okay.
Right.
I think it is recommended by Oracle to use FRA. Yes.
If you enable FRA, then you can able to get. Why Oracle recommends that one? If you want to enable your guarantee restore point, if you want to enable your flashback feature, FRA is must. Without FRA, you will not be able to use that feature, your flashback log, your guarantee restore point. That's the
Okay.
advantages. If you're okay, then I don't need to worry about guarantee restore point. I don't need to worry about flashback log. Then I'm not going to enable that flashback. Why Oracle recommends to support this guarantee restore point and restore point and your flashback features. And it's recommended to enable FRA, and all the flashback logs will go into your FRA. All right. With that, let's wrap it up. We'll continue on the coming weekend with our regular classes. We'll see you there. Thank you, everyone. Have a great weekend.
Thank you, Malik.
Yeah. Thank you.
Thanks, Malik.